Hey everybody, exciting times today. We got a lot of new features and exciting things to learn about in Inventor today. Things that are going to make stuff that was tough in the past now extremely easy and doable by machine. So check it out. You can see here that I have a part made, and this looks eerily similar to a quiz you might have just taken. And we're going to learn how to calculate some things based on that. First of all, let's take a look at something called the iProperties of this part we have here. Now we got a bunch of sketches. I should probably delete those in the browser. I don't like having useless sketches cluttering everything up. It's really just one sketch and an extrusion right here. Let's see, how do we get to the iProperties? There's two ways to get there. One is you can come over here to part one and you can right click on it and you can come down to iProperties and open it up right there. The other thing you can do is you can go to the search bar and type in iProperties and you can find it and open it right there. Now, most of these aren't very useful to us. These are kind of things for like, keeping the flow of the project going, engineer approved by, approved date, manufacturer approved. We don't really use those kind of things. But the physical properties have a lot of interesting stuff right here. So check it out. If you click update, you can see right here the mass, the area, and the volume. The area is actually the surface area, and the volume is right there as well for us. So you can see this actually perfectly has 25 cubic inches of volume, 110 square inches of surface area, and it weighs 0.903. Now, as you know, the mass is tied directly to both the volume and the density. So if we change this material from generic to, let's say, we go something like gold, which we know is heavy, you can see now all of a sudden the volume didn't change. It's still 25, but all of a sudden the mass weighs 17 pounds. So it got a lot heavier switching it from a generic material to gold. If we choose something lighter, let's say, let's see if aluminum's on here. There's a couple different types of aluminum. Let's just go with the 6061. Now it's back to weighing just 2.4 pounds. So there you go. You can find the mass, the surface area, and the volume of that. So you're allowed to use this now. If you don't want to use the formula sheet, you can just make it on Inventor and find the surface area and the volume. Or if we have complex parts, of course, that's going to be extremely helpful. So that is the iProperties. Very useful as well. Now let's take a look at something that might help us with our tipping force issues here. Now this isn't a perfect solution. It doesn't just give you the answer to doesn't just give you the answer. What's the volume? Well, there's the volume right there. But it will help you kind of discern the trickiest thing. As we know, we have two distances, right? The distance, the height of the tipping force, and we have the other distance, which is the distance of the center of weight, the center of mass. How far away is that from the tipping location, the tipping point? So let's take a look at how we might glean some insights right here as to where that center of mass is. It's actually going to help us be more precise too. So typically, and you know what? Let's just take a look at it, and then we'll go through the whole talking thing. So let's see. How do we get to this? Now we messed it all up. Let's get it back here. Okay. So let's go to our tools, or is it view? Yes, let's go to view. And now let's click on our center of gravity tool right here. And you can see where the center of gravity is. And if you spin it around, you can see it in all three dimensions. So actually the center of gravity is right here, kind of on the edge. It's not even inside this piece right here. That's probably because this thing sticks out so far. It actually pulls the center of mass further to the left instead of being inside this chunk right here. So there you go. There's the center of weight, the center of gravity, center of mass. All of those terms don't mean the exact same thing, but they're very similar, right? They're kind of interchangeable in some contexts. So there we go. That is good. Now, how are we going to use this to actually help us solve a problem? Here is what we're going to do. And we're actually not going to use this. We're going to use a drawing. So this is a quick refresh. If you forgot how to do drawing, we're going to go to File, New, and we'll create a new drawing. So here we go. Create a new drawing file. Probably going to take a sec to load up here. Here we go. Okay, perfect. Let's base this. And we'll put it on there. All right, there we go. Perfect. Now you can decide which way you want it to be facing. this way or this way. I might, which way is it facing on the, you know what was facing the other way on the test? So let's do that. There we go. Okay, and we'll put it right here, and I'm gonna increase the size just a little bit to make it a bit easier. Okay, there we go, 2:1, and we'll click OK, and we got it's making us save it in documents. That's fine. Now I want to give it a specific name, so I'll just go with test wall, or maybe I should say retaining wall, because I believe that's what it was. Wall. There we go. Okay, and there we go. We've placed it. Now we can, of course, go to annotate, and we can put some dimensions on there. And the dimensions turn out kind of small, but we can increase the size of them. Let's click OK. We can zoom in. Okay, that's 6 inches, right? That's good. And if we want to change the size, we can double click on that. We can hide the dimension value. We can type in 6.0. Now we can edit the 6.0. Taking a second to load here. Uh-oh. Yeah, all right. We're hanging by a thread. Hopefully it'll work and won't crash on me. That would be unfortunate. I would have to re-record. Yep, stay with me, stay with me. Okay, all right. So we'll change this to maybe 0.32, something like that. And there we go. We can see it's much larger and easier to read right now. Okay, now a couple of other things we can do is we can make sketches. So if you want to make a sketch, for instance, of where the force is coming in, you can do something like this. You could start a sketch right here, and you could draw a arrow that goes like this right there. And then you can finish the sketch, and you got an arrow kind of right there. Now, if you want to know that, okay, that's our force, we can go right here. We can make a text box, and we can say, did that work? Oh, yeah, it's that slow load. Okay. And again, we want to change the size, make it a little bit bigger. 0.32, and we can type in something like tipping force. Perfect. Okay, now we've labeled our force. Maybe we would want to use a leader text to kind of like point out, okay, that this right here is our tipping point right here. Again, I apologize for the slow loading. Right here, 0.32, and this is our tipping point. Okay, there's the tipping point. Got a nice little arrow pointing to that. We've got our dimension on here. Now the key thing, well, all right, now we probably want to add a couple of dimensions in here. One is we want to add in the height of the tipping force, because of course that's going to be critical right there. So we'll add in our height of our tipping force, which is 4.0, and we'll highlight it, and we'll click on the pencil. This is probably an unwise choice. Maybe I'll just write it out. We'll put in 4.0. We'll change the size right here. 0.32. Click OK. There we go. Oh, something didn't work. Okay, well, I'm not going to mess with it. Let's get to kind of the key point here. Let's, how did I do this? Tools, view. Let's see. Annotate, place views. Now I can't remember where this is. Let's see if I can find it. Center of mass. No. Center of gravity. No, how do we do that? Okay, I'm gonna have to think hard here. All right, so I believe actually what we do is if we go into the retaining wall and we find it, let's see, sheet here, sketch one, no. We need to find the part right here within our browser over here. So let's see, let's open all these up, border, sheet, format. So all this is our drawing tools, sheet one, view one, retaining wall. Okay, so if you open the view one, the view that we placed, this is the retaining wall, and then there you can find actually access to the part, and you can see like even the same stuff we had in our browser, the extrusion one. It doesn't let you edit it. I don't think it doesn't let you change it, which is probably good. So let's see, we're going to right click on this, and we're going to click on center of gravity right here, and it's going to place the center of gravity in. Now you can see that normally we've been assuming like, okay, let's just put the center of gravity right in the middle of these, but this actually shows us, no, it's a little bit more precise than that. It's actually way off to the right here because look, we have all this mass over here and we have so little over here. So it kind of actually shifts the balance of where the center of gravity is over to the right here. So we can use that right there. And now let's do this. Let us annotate and add a dimension between our center of gravity and our edge right here. 4.52 is what it's looking like. Okay, so we'll do 4.52, and then we will edit that so it's easier to read. You don't have to do this. If you're just looking for the number, it's probably fine, but I like to do a good job. Let's see, we'll go 0.32. Perfect, and okay. All right, so now we have everything we need, really. We know the tipping force from the test. It was 1,200. Oh, sorry, we're finding the tipping force. We know the weight of the wall is 1,200 pounds. And now we can kind of use this to help us find the most accurate version of our dimensions. 4.52, and then our height, of course, is 4.0. We didn't really need Autodesk to help us find that out, but it's kind of good to see everything visually laid out. And hopefully that will allow us to kind of understand the tipping force process a little bit more and kind of see like, okay, where did these dimensions come from? So that's what you got to do. You have to make these parts and then model them and then solve the equation using these values right here. Thanks for watching. Good luck.